Hello everyone. In many of my videos I've talked about how there's a difference between mechanical energy, electrical energy and thermal energy, even though they can be measured with the same units of joules or kilowatt hours or any energy unit. But I never really explained this difference, so let's try to introduce this problem now. It's not a very easy problem, it can get very difficult, but I think I can give you some easy example to make you understand this difference. So let's talk about something practical. So an example we used before is heating up water. You can do that in your house in different ways. For example, you might use a gas stove or an electric stove or an electric kettle. Let's consider the comparison between gas stove and electric kettle. If you have access to both electricity and gas in your house, these two kind of energy come from different grids, one from the electrical grid and one from the pipelines. To make an easy comparison, let's make a simple assumption. And let's consider that all the electricity produced in your country is produced with natural gas power plants. So as you can understand that the source of energy is the same. Once is natural gas and the other time is electricity, but electricity is produced with natural gas. So basically you're using the same source of primary energy. So let's now define what is primary energy and what is an energy vector like electricity. So primary sources are those that are found in nature in large quantities and that are used as a source. So they don't need to be created. They are out there. We just need to gather them. The most common examples that are used nowadays are oil, natural gas, coal, nuclear, the sun energy and all the energy that's derived from the sun, and the geothermal energy. Energy vectors instead are created by humans and are used to transport energy and use it in different forms. This is mainly electricity. Nowadays we're seeing more and more hydrogen, many forms of chemicals that don't exist in large quantities in nature but are created by humans to be used later in other conditions. But anyway, electricity is the main energy vector that is out there. So now let's consider the losses that we have on these systems that are needed to transport energy from the extraction point to your house. First of all, we need to consider the primary to final energy efficiency. So what is primary energy? Primary energy is the energy associated with the source of energy, so the natural gas in this case. Final energy is the energy that reaches the user, which the user can be you or an industry or anyone else. So if we consider the natural gas pipelines, we can see that the efficiency from primary energy to final energy is very high. It can be more than 99% or anyway very high, for sure higher than 95%. Why is this? Well, because basically some of the energy is needed to pump this natural gas so that it can flow through the pipes and actually reach your house. But this energy is very little compared to the energy that is actually contained in a chemical form in the natural gas. If we consider the other system instead, so the electric grid, we can see that in the power plant, the efficiency of conversion is a maximum around 55%. And this is not because the power plant is a bad one or because the guys who run it like wasting energy, but it's because there are some physical and some technological limits to the efficiency that you can get in a power plant, and actually 55% is around the maximum that you can get in a commercial power plant. And I will explain why in some other videos. So basically you're taking 100% of your natural gas, or even less than that because you might already have lost some on the way, depending on where the power plant is, and you're transforming it to only 55% of electric energy. So it must seem like natural gas is the better option because you're using less primary energy for each amount of energy that arrives to your house. Well, this is true, but the problem is not concluded yet because we need to consider another kind of transformation, which is the transformation from final energy to useful energy. Because what you need is not natural gas in your house. What you need is, for example, heat or hot water. So continue with the example of hot water. If you're boiling hot water in a pot on a gas stove, of course not all the heat released from the combustion would flow inside the pot, but some of it would be released and wasted in the environment. And for example, as we showed in other videos, a pot can have an efficiency between 10% and 60%, I'd say, but an average value can be 40%. When an electric kettle can have actually a final to useful efficiency of more than 90%, and maybe can reach around 95% or more. Now, to understand the overall efficiency of the two methods, multiply the primary to final efficiency times the final to useful efficiency, and you get the primary to useful efficiency, which is what we're looking for here. You can see that despite the fact that the electricity is a more expensive form of energy, in this case, you will end up with a higher efficiency for the electric kettle than for the gas stove for heating up water. But for other purposes like heating up your house, usually gas can be better unless you use electricity to run a heat pump which has an efficiency higher than one. So of course, the problem is always much more complicated than this because no energy grids runs completely on natural gas. You will always have some coal, some renewables, and then you have to consider not only the energy consumption but of course the CO2 emissions and all the other kinds of emissions and all the different kind of impact that a source can have if you really want to become more sustainable. But this is just to make you understand more about how the energy systems work and all the things that we need to consider.